Hello viewers, welcome to the session on types of data in clustering analysis. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So the type of variable in clustering analysis that we are going to discuss in this video are interval scale variables, binary variables, nominal or categorical variables, and ordinal variables. So firstly, let us have a look at what are interval scale variables. So internal scale variables are continuous measurements of a roughly linear scale. And for this, the example can be weight, height, and temperature. The dissimilarity between the objects described by interval scale variables is measured by popular distance measures like Euclidean distance and Manhattan distance, and the formulas for both has been provided here. So let us now understand the internal scale variables through a numerical example by using Manhattan distance. For this, consider a data set which is having information about student ID, name, and their respective weight. And our task is to find a group of students or student who is much similar to student ID 1, that is Ramu. And further, we are going to make the use of Manhattan distance. And how can we use it? See, what we are doing here is we are calculating the dissimilarity value of all the students with respect to student 1. See, dissimilarity value of student 2, that is object 2 with respect to object 1, is 62 minus 60, which is nothing but 2. And it has been calculated for all the remaining students. And as we have already discussed in our earlier videos, that lower the dissimilarity, higher is the similarity between the objects. And from this, you can see the dissimilarity value of 1, 2 and 1, 5 have the lowest dissimilarity value, which means they have higher similarity. So what you can conclude from here, that students with student ID 1, 2 and 5 can be clustered. So let us now jump into second type of data in clustering analysis, that is binary variable. So binary variable is a variable which has only two states. And for example, it can be 0 and 1, or true or false, or yes or no. And to compute dissimilarity between the objects described by binary variables, we consider a contingency table which is represented as follows. Here you can see that object I is stating true and object J is also stating true, then the value is A. Means A times both are saying that the value is true. And the object I is stating true but the object J is stating false, then the value is B, which means B times the objects are having dissimilarity. So from this you can tell me what is the dissimilarity. It is nothing but when object 1 is stating true but J is not telling that it is true. And similarly, when object I is stating false but object J is stating it's true. So the dissimilarity here is B and C out of the whole data set, that is A plus B plus C plus D. And before getting into this, let's clear the basic terminologies that we use here. It is nothing but if both the states are equally valuable and carry same weight, then it is a symmetric binary variable. And the example of this can be gender, in where each state, that is male and female, carry an equal amount of weight. And it is a asymmetric binary variable if the states are not equally important, that is they do not carry same weight. And for the example, you can consider the positive and negative result of a medical report or test. So as we have discussed in the earlier slide, dissimilarity between the objects I and J for symmetric binary variable is B plus C whole divided by A plus B plus C plus D. And here A plus B plus C plus D is nothing but the values of the whole data set, whereas B plus C are nothing but the dissimilarity values. And similarly, the dissimilarity between objects I and J for asymmetric binary variable is D of ij equal to B plus C divided by A plus B plus C. And here the reason for not considering D is because here both the states are not equally important. that is, they are not carrying the same weight. So let us now consider a numerical example to understand binary variable. Let us suppose we are having a data set in which we are having the information of patients and their gender and whether they are having fever or cough and what does test 1, 2 and 3, 4 respectively says. And as we have discussed in the earlier slides, here gender is a symmetric attribute and the remaining attributes are all asymmetric binary. So let the value of y and p be set to 1 and the value of n be set to 0, then our data set will be transformed into something like this. So now the task is to find the similarity among the patients, and as we have already discussed about the contingency matrix, now we are going to use the same to calculate the dissimilarity value for asymmetric variable, that is b plus c whole divided by a plus b plus c. And for calculating the dissimilarity value, see what we have done is, first let us consider the case of Jack and Mary. Let us suppose the object I is Jack and J is Mary. So then what we are doing, the value of b, what is b? Jack is stating it is 1 and Mary is stating it is 0. Is there any case like this that Jack is stating 1 and Mary is stating 0? No, here Jack is stating 1 but both are stating 1 only. So no case is like that, so we have considered it as 0. Similarly, the value of C is nothing but Jack is stating 0 but Mary is stating it is 1. So is there any case like where Jack is stating 0 and Mary is stating 1? Yes, we are having one such record like that. So we are substituting the same values, and same values of b plus c divided by a plus b plus c has been calculated for each of the patients with respect to Jack. And let's find the clustering between among the patients here. From this we can see that the least value is 0.33. The dissimilarity between Jack and Mary is minimum, hence they can be put into one cluster. So let us now understand about nominal or categorical variable. So nominal variable is nothing but a generalization of binary variable. Here it can take more than 2 states. For example, colors can be red, yellow, blue and green. And the dissimilarity value here, it can be calculated by using the formula p minus m whole divided by p, where p represents total number of categorical variables in the dataset and m represents the number of matches, that is I and j objects are in the same state. So let us now understand nominal variables through an example. Here we are having a data set of an organization where there is information about employee ID and age group and work category, where age code ABC represents that the employee's age range is among these areas, and work category XYZ represents that X means it is daily wage, Y means he is a permanent employee, and Z means that he is a contract based employee. And the number of categorical variable here is 2. As you can see, we are having only age code and work category. And as we have discussed in earlier slide, the formula of dissimilarity can be calculated as p minus m by p, where p represents the number of categorical variable. Here we are having 2 categorical variables, age code and work category, and m represents the number of perfect matches. And from this we are just substituting among different employees. Here the dissimilarity value between employee 1 and employee 2 has been calculated. Number of categorical variables are 2, so it is 2. And number of matches, see how many matches are there. Do they both belong to same age group, age code? No. Do they both belong to same work category? No. So that's why it is 2 minus 0 by 2, which is equal to 1. Similarly, the dissimilarity value between employee 1 and employee 3, do they belong to the same age code? Yes, A, 1 categorical value has been matched. Similarly, do they belong to same work category, X and X? So therefore, it has been matched. So 2 minus 2 equal to 0. So the dissimilarity value is 0. Similarly, it has been calculated between all the employees and it has been stated in this matrix. Now from here you can see the lowest dissimilarity value is 0 and it is between employee E1 and E3. And similarly, the next lowest value is 0.5, which is between employee E1 and E4. So what we can do is the lowest dissimilarity can be clustered together. Lowest dissimilarity means they are having highest similarity. As I have stated that between E1 and E3 it is 0, and then later between E1 and E4 it is 0.5, and the last one is between E2 and E5 which is 1. So how can be they cluster together? E1, E3 and E4 can form a single cluster, and E2 and E5 are different clusters. So let us now look at the ordinal variables in clustering analysis. And ordinal variables resembles a categorical variable except that the states are ordered in a meaningful sequence. For example, medals of sports has states in sequence as gold, silver and bronze. Similarly, in a department, we can have designation as professor, associate professor, assistant professor, senior lecturer and full-time lecturer. So now let's look at the algorithm that's working behind ordinal variables. The step 1 is, if f is an ordinal variable having mf order states representing the ranking 1, 2, 3 up to mf. Then the step 2 is, if x of if is a value of f for the ith objects, then replace xif with its rank rif. And the step 3 is to normalize the ranks such that they fall into a fixed range between 0 and 1, both inclusive. And the coefficient ZIF is equal to rank of IF minus 1 whole divided by MF minus 1, where MF is the ordered state. And the last step is, dissimilarity is computed using any distance measure like Euclidean or Manhattan on ZIF value as used in interval scaled variables. I'm pretty much sure that all of you are thinking, what the hell is this algorithm? Don't worry, it's going to be crystal clear when we are going to solve the numerical example. So let us first have a data set in which we are having the hall ticket and their respective grades. And let's look at the algorithm step by step once again by solving this example. So the step 1 states that first we have to know the number of states. So from here, from the data set, we can make sure that result is an ordinal variable with 4 states. So the MF is equal to 4. And what are these 4 states? And we have to rank them in a meaningful sequential order. So these 4 states are distinction, first class, second class and fail. And they have been ranked accordingly in a meaningful manner, 1, 2, 3 and 4. So what does the second step states? It says replace the ordinal variable values with its corresponding ranks. That's it. So now the data set is transformed and it will look something like this. We have just transformed it. Okay, now what is step 3 states? Step 3 is very simple. It's just nothing but normalization. We need to substitute our values here. ZIF is equal to RIF minus 1 by mark MF minus 1, where RIF is nothing but the rank of the particular object and MIF represents the state of the object. So it has been calculated for each of the state, that is 1, 2, 3 and 4, and its normalized value is 0, 0.33, 0.66 and 1. And now the task is, now we have to replace the rank values with the calculated normalized values, by which we have again transformed data set, and it will look something like this, as you can see here. Okay, now the step 4 states we have to use Manhattan distance measure to compute the dissimilarity matrix, and we have discussed how to calculate Manhattan distance. So it's just a repetition of the same, even though let me quickly tell you what we are doing. We are calculating the Manhattan distance between object 1, 1 and 1, 2. What we are doing is we are just getting the absolute values of that difference. 0.33 and 0 is 0.33. Similarly, it has been done for all the objects, and the dissimilarity matrix has been calculated, and we have found something like this. So now it's just a revision of what we have been discussed till now. So the least value, what we can see here is 0, and it is between object 1, 1 and 1, 4. See, you can see here. So they have been clustered together. Similarly, the next least value is again 0, and it is between 12 and 16. So again they have been clustered together. So the next is 0.34, which are having the objects 13 and 15. So they have been clustered, and when we look at it particularly and carefully, we can see that they can again clustered into 1, as they are having 0 as the dissimilarity matrix. Lower is the dissimilarity, higher is the similarity, and they can be clustered together. That's it. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.